Today this video I will teach you what is inside this APS 500 RS 500 VA inverter, which is a UPS uninterruptible power supply. Now see what is inside this power supply. This is a UPS, so you can see there are bottom side is a battery compartment, and there is its battery, which is used lead acid, sealed lead acid battery. In this case, this battery is 12 volt and this battery is dead. So under inverter is working condition, but battery is dead. So I show you what is inside this inverter. And there, back side, on off switch, power in, 4 outputs, and LAN in for communication between all the inverters, and some noise removing pins, because you may know FETs and modems need. When you turn on the FETs and modems with these devices, they generate noise, harmonic noise. In order to prevent the noise, there are two small circuitries used, which can take the data line and rectify it itself, which is produced by this inverter voltage, noise produced by this inverter voltage. And their front side indicator, their overload on battery, power on, and replace battery, and this is power on. Now it's time to open it and what is inside. But before that, BR500 input 230 volts, 6 ampere, 50-60 volt AC, output 500 VA volt ampere, 230 volt, 2.2 ampere, 50-60 volts, 300 watts of power, output surge protection, 30 volt, 3.8 ampere, 50-60 volts, and output total current is 6 amps. This inverter, and output harmonic noise is 40% to 30%. Now open it. In order to open this, we tend to like that first with side objects. What we tend to do, we open the inverter screws. There are 2 screws only, and this time this inverter is working. So I open the inverter and after reclose them properly without destroying. This time I am also expect this inverter contain too much components, so it may be difficult to reverse engineering. So I try to reverse engineering in next part and make the next part if it is possible. Now I remove the settings to there are total 2 screws, not more. And keep in mind, if you not have any idea about electronics, now open these kind of inverters or service it yourself, because it is a dangerous thing. If it is done condition, you are open it and touch any internal terminal or anything, you will that electric short. Now put the a little bit until fully pull out. There are 3 switches, output is parallel, and 2 input switches. So this is for input, I think, and this is at a setting inverter. So you can have all the inverter in parallel with single chain without using any other extension. And this inverter is not enough to drive any other loads, which is used only turn on 3 computers, 2 monitors and 1 CPU. And this is on off switch to turn on and off all the inverter at once. And this is main right to transformer, and there is a control circuitry. And this is a noise card, which is contain a fuse, PTC and resistors to remove a noise and send in these noise to a ground terminal for protection, for protecting any other equipment with noise. Now I pull this inverter out like that, and these are battery terminals which goes and output. Let me wait, I go close to it in order to open properly. I remove this clip and then see there is a iron to a transformer, step up transformer, input first, input doors. This test you may see clearly screw are not falling down. These are neutral, both the sides neutral will turn together. So input and output neutral is turn together. So neutral is also always same. Live neutral those MOV, then those capacitor, then those line filter coil, then those another capacitor, then those two ceramic capacitor, and then those line fuse which is somewhere there, and then those to the line filter coil, and then those diode. So there are fuse there, 2.5 ampere fuse there. Showing the top. This fuse to this inductor coil, to this rectifier, and then those main capacitor. There is an IC which drives this transformer with help of this MOSFET to the step down. Then turn is 12 volt, and this 12 volt goes there's fuse. There's a fuse which fuse then those these terminals to charge a battery, and once battery is charged, then voltage goes to this MOSFETs. H bridge, this H bridge is switching the PWM control circuit, switch the H bridge with the help of these three heavy gauge wires to this transformer, and this transformer is step up the voltage by these wires, and each time output the various voltages according to the temporary. So it is a universal inverter. It was every temporary, so 120, 220 and 440, and any time 230 volts. So there's quite a tap common 60, 120, 180 and 240, and these are connected by these relays, and these relays controlled by this processor. And what happens, this relay output is connected to the output. So it's when you plug this inverter to according to a temporary voltage, it's measure the voltage. This IC measure the voltage, how much voltage the temporary is available already, and same voltage it can also give output. So if you mean this inverter to charge by 120 volt AC, and it is also give 120 volt AC out. If 220 volt AC is applied input, it is also give 220 volt AC is out. And if you give 160 volt AC input, and it is also give a 160 volt output, AC output. So this is a multiple taps. This relay just output voltage, output step up voltage according to input voltage. And there is a H bridge because this is a sine wave, and there is a mystery driver circuitry in SMD form. This is a main processor, and there is some IC, maybe MOSFET driver is. Now it's time to seeing and continue the video. I think it is take up to quite a bit of time. This is also relay, so I'm see and reverse engineering and then continue the video in after about next part or in this part. Pause.